And we're live! Woohoo! We're back from Math 60, Intermediate Algebra, Polynomials, 5.3, pages 1 and 2. Woohoo! And right off the bat, I'm going to start off with a correction to the notes because I don't like the way I wrote it. We're going to introduce the concept of polynomials, which if you're in intermediate algebra, you've probably seen these guys before. In fact, technically, every time you've written a variable, it has technically been a polynomial, most likely, unless you did something really fancy with it. So polynomials are expressions built out of a combination of multiplication. Let's get rid of division. That's complicated. Addition and subtraction. You can make the case for division, but the important thing about polynomials is in order to keep it a polynomial, you can't divide by a variable. So I thought that was just too confusing. So let's just make this into a super multiplication. There you go. We'll confuse everyone. Little multiplication and big supernova multiplication, addition and subtraction. We're going to make it out of constants. Oh my goodness, that was exciting. Constants and or variables. And let's talk about some examples of polynomials. One that people have seen a lot of is something like this: x squared minus 3x plus 2, something like that. That's very exciting. We've got multiplication, x times x, subtraction, subtracting 3 times x, and addition, adding 2. Now, technically, it could also be something like x to the 452nd times y plus z. So it could be kind of entirely made up of variables and their powers. It could be as simple as the number 5. That technically counts as a polynomial, although it is considered trivial. So it's not really following the rules, but technically you could make the case. But a lot of times polynomials are going to look more like this. There are lots of simple ones like a plus 3 and all sorts of other things. For the most part, we're going to stick to certain types. So let's talk about some wonderful vocabulary. So first off, a really fun word to say, monomial. This is a polynomial with one term. And so instead of explaining what degree is, because, I could give you a couple sentences on what degree is, I'm just going to show you what the degree of a polynomial or specifically of a monomial is. And then you can try to guess what it is. So I think that's way more fun, at least for me. So a monomial has one term. So there's no plus something or minus something. It's just a single term. For example, just x, and the degree of x is 1. Now, if I have 3x squared, that is also a monomial, and the degree of that is 2. You might be starting to get the idea. If I have the opposite of x cubed, the degree of that is 3. So you're starting to put it together. It has something to do with the exponents. Now, this is a complicated one. I pulled this in just to give you a preview of what's coming much later on in math. For the most part, we won't be seeing anything like this anytime soon. 14x times y to the 4th. That's a mouthful. But if we were to see this, the degree would actually be Dora style. Go ahead and give me an answer. And I'm going to have to say some of you yes, some of you no. The degree on this one is actually 5. And then for 6, there are no variables, so the degree is 0. And so what is the degree? The degree has to do with the exponents. Basically, if there's just one variable, it's whatever the exponent of the variable is. It's the power. Or if you've got a bunch of variables mixed together, you add their exponents or add their degrees. So that's why this is 1x, 4y's, altogether the degree is 5. So those are monomials, and those are fun, but they only get us so far. So next up, binomials, the party polynomials. Binomial is a polynomial with 2 terms. You can have 2 terms added or 2 terms subtracted. Now, there's a new concept here. There's a leading term. There's like the boss term, and then there are all of the minion terms. And I'm going to say the boss term on this first polynomial is x, and the degree of x is 1. Next up, 3x squared plus x, the leading term or boss term, 3x squared, and the degree of that one is 2. Next up, and this is where people sometimes look at this and go, wait, this isn't what I thought it was. 3x minus 14x cubed, the leading term is actually negative 14x cubed, and the degree is 3. So do you see what the pattern is? What is the leading term? You're right. The leading term is the term in the polynomial, or in this case, the binomial, that has the highest power, the highest exponent, the highest degree. Notice that I don't add the degrees. So like with 3x squared plus x, I don't say 2 plus 1 to get 3. I just look at the power of, or the degree of, the leading term. So there is a difference here between things that are added and was up here when they're multiplied. When they're multiplied, yes, we add the exponents, but when they're added, we do not. And this comes from the fact that regardless of what else we add in here, if the leading term, so in other words, the term in the polynomial with the highest degree, if it say is a 3x squared, so it's an x squared term or a second degree, then anything else you add on that's of a smaller degree will not change the basic graph and the basic behavior of this. So we're going to start qualifying things, quantifying things on the basis of their shape and their behavior. So we look to learn the leading term for that. Okay, next up, trinomials. You can see we could keep going for a long time. Generally speaking, we're just going to talk about monomials, binomials, and trinomials. These are polynomials with 3 terms. And here I've written this one up, x cubed plus 3x squared minus 1. Again, the leading term is the term with the highest degree, the highest exponent. But it doesn't necessarily have to be the first one. Now, if we look through this one, I've got a term right here, x squared y to the 4th. That's going to have a combined degree of 6. This is a degree of 14. This is a degree of 0 because there are no variables in it. So it's 0. It's the constant term. So my leading term is negative 16x to the 14th, and the degree is 14. And again, you don't have to stand in front to be the leader. In fact, this is a really good point that leaders frequently lead from the middle or from the back. How's that for some philosophy mixed in with your math? Okay, let's go on to the next page. Woohoo! Now this next page, it has to do with a promise I made someone once, and that is that I promised I would always teach ascending order, even though, don't tell her, don't tell Mary Kay, but I don't know anyone who actually uses it. But I promised her at one point that I would always teach it. And so you never know when she's paying attention, so I've got to do it. So 4x to the 4th minus 3x cubed plus 6x squared minus 1. This is called descending, so in other words, going down order, because I started with the highest power and then I wrote them in order of their powers or of their degrees of their exponents. 4th degree, 3rd degree, 2nd degree, 0. Ascending order would be a little bit different. It would look like this. And remember, whenever you change the order of terms, certainly in polynomials, the sign that comes before the term is the sign that term gets to keep. So the plus stays with the 6x squared, the minus stays with the 3x to the 3x cubed or 3x to the 3rd, and the 4x to the 4th has a plus because it didn't have a sign, so that's understood to be a plus. Okay, so the question that people often ask is, oh no, what if there are 2 variables? Like there's a bunch of stuff going on with x's and y's, and the answer is we're not going to talk about that much. I know I brought it up and now I'm saying we're not going to worry about it. And of course, now you're worried about it. But the answer is I just kind of wanted to plant that seed for when you get to calculus and things start to get a little more interesting. Not that this isn't very interesting. This is so interesting so far. But to be honest, when we try to decide how to write out polynomials and we're working with more than one variable, there are going to be other considerations, things that I'm not going to bring up right now. So you know what? For now, you can arrange in descending powers of x. So for example, pretend there's no y there at all, and you just do negative 16x to the 14th plus 4x squared y to the 4th plus 2. That's one way to do it. Another way to do it would be to put this term either at the beginning or the end because it's different. It has the x and the y mixed in. And there are a lot of other ways to deal with that. So I would just say, don't sweat it too much. It's not going to come up a lot. Maybe a problem on WebAssign, and then there's a couple semesters of forgetting it. And then it'll just be a happy, happy surprise in calculus. Oh, you know what I did? I just said all of that without letting you see it. Sorry. It's magic. Look, ooh, it's all written. Magically prepared. So in order of x's, x to the 14th, then x squared, then the constant term. And again, this term, because it is interesting, it's got the x and the y blended. It might come at the front. It might come at the end. That's something that you're going to discuss with your calculus teacher. Find out what's right for you. Okay, next up. Well, we can't learn about anything without someone having to bring up functions. So now we've got polynomial functions, basically a function that looks like a polynomial. So how do we do this? And the answer is exactly the same way we would do anything else. If I want to find p of 5, then I would go ahead and plug in everywhere I see an x here. I would put in a 5. So I've got the opposite of 5, the quantity squared, plus 4 times 5 minus 1. And if you haven't seen me do functions, I almost always put in parentheses wherever I've got an x because I find that a lot easier to work with. So let's see, this is going to be negative 25 plus 20 minus 1. Oh man, I think this is negative 6. I hope it is because our motto is one take and that's it. So hopefully it's negative 6. If you suddenly hear it redubbed and I'm like, and that equals negative 13, then you'll know that I made a mistake. Okay, so next up, what if I plug in negative 5? Now here's where you start to see why I put parentheses in. If you put parentheses wherever you see the variable, then you're not going to run into troubles with like, is this minus going to get squared? Is it not going to get squared? This minus is inside the square. So it absolutely will get squared. So this minus comes down, but this negative 5 squared, I have no idea where that came from. Oh my goodness, so much for one take wonder. Let me try that again. The minus is right there. 25, that was hilarious, wasn't it? Minus 20, minus 1. This was a bad day for someone. Negative 25. Again, negative 5, the quantity squared gives you positive 25. Pardon me. 4 times negative 5 is negative 20. And the minus 1 comes on at the end. And I think this ends up being negative 46. Woohoo. Woohoo. Okay, awesome. We've got one more page of this introduction to polynomials, and then we get on to multiplying them. I know you guys are very excited. And the F word. Not in the next video, but in a couple videos, I'm teaching you the 4-letter F word. You got it. You heard it right here. I'm teaching you guys the F word.